So let's keep going. It says, how does the graph at the right compare to the linear parent function y equals x? We're talking about when it says the graph at the right, really we're talking about this equation, okay? So the slope is 2. Well, the parent function has a slope, an imaginary slope of 1. So it would be steeper, okay? Because the slope is 2, it's greater. We also have a y-intercept of -3. Well, the parent function has a y-intercept of 0. So I need to make sure that I write that it has been shifted down 3 units. Okay? Explain how the graph would change if the 2 in the equation was changed to a 5. So part A says, how would the steepness change? Well, it'd be even steeper. The higher the number, the steeper it's going to get. How would the y-intercept change? Well, it wouldn't, right? If we only changed the 2 to a 5, the 3 is not changing, so it would be okay. How would the x-intercept change? Well, okay, so let's think about that. If this is my graph, and I've got 2x minus 3, so I've got a y-intercept of -3, and my slope of 2 makes it look something like that. Well, changing it to a 5 is supposed to make it steeper, right? Same y-intercept, but steeper. Did my x-intercept change? Yes. Oh, I guess they're not asking me yes or no. They're asking me how would it change? It would actually decrease in this situation, okay? There's no rule for that. It's just think about it. You probably could come up with a rule, but I'm not asking you to memorize a rule. I'm just wanting you to think about it. If I've made it steeper, in this case, the x-intercept is going to decrease, okay? But that's not always the case. For example, if it was negative and I made it steeper, my x-intercept would increase. So don't try to memorize a rule. Just think about what would visually happen to the graph. Then it says, how would the direction of the slope change? Well, if I'm just changing it to a 5 from a 2, there'd be no change because it would still be a positive slope, okay? This is what changes would occur if the equation is changed to y equals 1/3 x plus 6. Well, again, if I'm starting at a 2 slope and going to a 1/3, it's going to get flatter, or you could write less steep. That's probably a little bit better English there. If I'm going from -3 to a 6, that means that it has been shifted up. How many units? 9 units. Okay, because I'm going from a -3 all the way up to a 6. That is a total change of 9 units. Okay? Then it says, explain what would happen if the slope of the function would change to -1/2. What is the relation between these two lines? So going from a 2 to a -1/2, well, it's obviously going to be flatter, and it's going to change direction. However, we've also learned something else about that. These are opposite reciprocals, right? Which means that these two lines would be perpendicular. So if you reflect it and make the slope a reciprocal, they're going to be perpendicular. All right, so number 10 says, without using a calculator, describe the change of the graph from y equals 3x plus 2 if the equation changes to y equals 2/3 x minus 4. So talking about the slope first, we're going from a 3 to a 2/3. It's going to get less steep or flatter, either word, doesn't matter. The y-intercept, it's going from a 2 to a -4. So we're going to say it shifts down 6 units. Make sure you get that 6. If this is my graph and I'm starting at a 2, going down to a -4, that's a change in 6 units. Now the x-intercept, again, you have to think about this one. I'm going to sketch out my graph. 3x plus 2, it's going to look something like that. If I make it flatter and move it down to -4, it's going to look something like this. So that means my x-intercept is going from this point right here to over there. So that means my x-intercept is going to increase. I'm not going to write how many units because that's not really the point of it. It's just to consider that that's obviously going to change as well. We could plug in the numbers, right, because an x-intercept is always a number than 0, but we don't need to do that. All right, next one. Changing from 2x minus 3 to 4x plus 3, the slope is going to get steeper because it's going from a 2 to a 4. The y-intercept is going from -3 to 3, so it's going to shift up 6 units. The x-intercept, again, you have to kind of sketch this one out. 2x minus 3, so that's going to look something like this. And we are changing it to 4x plus 3, so way up here. 4x is steeper, so we're going from an x-intercept here to here. So it is going to decrease. Number 12, write the equation of the graph after it has been translated up 6 units and the slope has been changed to a -5. So, the first thing to figure out the equation of this line. Well, my y-intercept is 3, and my slope, it looks like, is -1/2. Y equals -1/2 x plus 3. So if I'm changing the equation to a -5 for its slope and translated up 6 units, well, if I'm starting at the 3 going up 6 units, that's going to end, at 9. Then it says, write the equation of the graph after it has been reflected over the y-axis and the slope has been doubled. So we're going to go back to the original equation here. Reflected means it's now going to be a positive slope. The slope's been doubled. Well, 1/2 doubled is just 1. So I really just got a slope of 1. Same y-intercept of 3. 2 more questions. Taxi company uses the equation y equals 0.50x plus 250 to model their cost y for driving x miles. If the company changed their rates and their equation y equals x plus 250 is now used, what changed? Well, the 250 stayed the same. It's the 0.50 that changed, right? Well, thinking about this story for this taxi company, that is going to be their rate, their mileage rate, right? So they increased, because we're going from a 0.50 to a 1, their cost per mile. In other words, their slope, right? They increase the cost per mile. Okay, number 14, given the function f of x equals 3x minus 4, how does the function g of x equals f of x plus 6 compare? Write the new equation for the function g of x. Remember that all these f's and g's just mean y's, right? So if we have y equals 3x minus 4, how does a new equation, right? That's what this g stands for, is a new function where we take the old equation and add 6. Well, let's take this old equation and add 6. Well, combine like terms here, and we're going to get y equals 3x plus 2. Or, to use their terminology, this is really g of x. So that's my new equation, and we're going to say that it has been shifted up 6 units. Okay? Now, I know this lesson's kind of weird, and it's not quite as clean and pretty as lessons we've done in the past, but really it's just all about making sure that you are in the right mindset to analyze changes that occur to linear functions. So before you think, oh, I'm not so sure about that, try the homework, try the practice. It's in Schoology, and just see how you do initially. Okay, if you still feel unsure or shaky after looking at the practice and maybe comparing with some friends, then make sure you talk to your teacher, go by the tutoring hub.